Where do elements come from? An overview of the stellar processes that create elements in our universe. The early universe. After the Big Bang, in the early universe, the only elements that existed were hydrogen, helium, and lithium. Hydrogen and helium are the most abundant elements in our universe. The current accepted models of galaxy formation agree that large clouds of hydrogen and helium collapsed to form the galaxies, stars, and solar systems. The question is, where did all the other elements come from? This article was created to explore the many processes in our universe that create elements. It helps explain how we got to the point where the universe has so many different elements in different amounts. Nuclear fusion. What is the power of stars? How does nuclear fusion create elements? The process of element atoms fusing together to form heavier elements is called nuclear fusion. In order for nuclear fusion to occur, there needs to be a lot of heat and pressure. In the universe, the most common place for nuclear fusion to occur is in stars. It is the power of stars. Stars start off by fusing hydrogen into helium. Then, depending on their size, they also create other elements. They create the 12 most common elements: carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, argon, calcium, titanium, chromium, and iron. These 12 elements make up over 90% of Earth's mass. After hydrogen and helium, they are the most abundant elements in our universe. All these elements and more are created by the power of stars. When smaller stars come to the end of their life cycle, they create a planetary nebula. It happens when a star blows off its outer layers because it ran out of fuel. This is one way elements are released into the universe. Nuclear fission. How do heavier elements break down into lighter elements? How does nuclear fission create elements? Nuclear fusion is when two lighter elements combine into a heavier element. Nuclear fission is the opposite. It is when heavier elements break down into lighter elements. This process occurs when heavier atoms split apart and form lighter ones. One of the most common reasons that this can happen is when a neutron collides with an atom, and this causes the atom to split. This process happens in outer space when the conditions are favorable. It can happen in small amounts inside stars that sucked up heavier elements in their formation process. Fission occurs on Earth in nuclear reactors. Fission can also happen in interstellar space. For example, when a heavier element encounters a gamma ray burst. This process is known as photofission. Heavier elements breaking down into lighter elements by the process of nuclear fission is responsible for the creation of elements. While nuclear fission is not the main contributor of the creation of elements in our universe, it is a way for elements to be created and is worth mentioning. Neutron capture. How can neutrons be used to create heavy elements? How does neutron capture create elements? Nuclear fission requires a large amount of heat and pressure because the electrons cause an electrostatic repulsion that prevents the atoms from fusing. The larger an atom is, the more electrons it has, and the more heat and pressure is required to cause fusion. A free neutron is just a neutron, and it has no proton or electron. It has no electrical charge and can enter the nucleus and fuse with it easily. Most of the time, the product of the neutron capture process is very unstable and quickly decays into something else, with the exception of helium, which actually forms a stable atom. When this happens, the atom does not just reject the extra neutron and go back to what it was. Instead, it turns into another element that is stable. This means that neutrons can be used to create heavy elements. Neutron capture is a great way to make larger elements. Unfortunately, free neutrons don't really exist in most places of the universe. Neutrons on their own are unstable, and will decay into hydrogen in a short period of time. In order for neutrons to be used to create heavy elements, there needs to be a place where free neutrons exist. For example, where nuclear fission is taking place. Supernova. What is a supernova? How does a supernova create elements? When the fission in large stars stop, they explode in a process known as a supernova. Elements that are heavier than iron are created during a supernova. Supernova nucleosynthesis is the creation of elements in a supernova. It is the way supernovae create elements. There is still a lot to learn about supernovae. We know that the heavier elements are created in supernovae, and a common belief is that there are processes in supernovae that create an environment that allows neutron capturing. This process is believed to be how supernovae create elements and is responsible for the creation of heavier elements during the supernova event. A supernova is a very large explosion that ejects elements and compounds into the universe. It leaves behind an expanding cloud of gas and dust called a nebula. Many of the elements in our universe would not exist if it was not for supernovae. Radioactive decay. What is radioactive decay? Does radioactive decay create elements? Many elements heavier than lead are unstable. This instability can cause the ejection of a neutron or a proton, or a neutron to decay into a proton and electron. Depending on how stable the element is, this process can vary in how long it takes. Radioactive decay does create elements. Lead is produced in supernovae, but the total amount of lead in the universe is greater than can be explained by the lead created by supernovae. The rest is believed to have been created by radioactive decay. Radioactive decay creates heavy elements out of even heavier elements. It is a process in our universe that creates elements and is a reason why our universe is what it is today. Cosmic ray spallation. What is cosmic ray spallation? How does cosmic ray spallation create elements? The process of cosmic ray spallation occurs when cosmic rays encounter other matter in the universe. This results in the expulsion of particles like protons, neutrons, and alpha particles. Sometimes this causes the effective matter to become unstable and break down into other elements. This is how cosmic ray spallation creates elements. Cosmic ray spallation is responsible for the creation of some of the lighter elements like lithium, beryllium, boron, and isotope helium-3. It is also responsible for the creation of other elements like tritium, carbon, phosphorus, chlorine, iodine, and neon. The cosmic ray spallation process that creates elements occurs in space, but it also occurs in Earth's atmosphere. This happens when cosmic rays come in contact with particles in our atmosphere. The universe is a very large and complicated place. Most elements were created in stars, but stars are not the only thing that create elements. In order to understand where all these elements come from, it is necessary to understand several processes. The events that led up to the current state of the universe have been going on for over 13 billion years. We've done a lot of studying and hypothesizing how it got to the point where it is today. We are limited in our knowledge and understanding due to the fact that our ability to observe the universe is limited to how good our observation tools are and methods are. For this reason, it's impossible to say exactly how and when all of our elements were created. We have, however, made a lot of progress and have learned a lot. What we know is very interesting and worth writing about. We hope you've enjoyed this article. If you did, please share the link with your friends. Also, feel free to leave any questions or comments in the comments section.